Without securing pods and clusters in your Kubernetes environment, the environment itself will always be in shambles. And it could be anything small, from a public IP address sitting on the control plane to a pod that's maybe using a default service count and you're not specifying one, to not using security context. And unfortunately, a lot of this stuff is kind of done out of the box. So like, for example, on a lot of the cloud-based Kubernetes environments, you have a public IP address on the control planes by default. When we're deploying pods, by default, you don't have to set a service count, but you really should have to. When you're setting up a pod manifest or a deployment manifest, by default, you don't have to set security context. So a lot of these security issues are all about misconfigurations. Unfortunately, a lot of these misconfigurations are out of the box, but in this video, we're going to go through a couple of steps from a pod perspective to secure those pods within any Kubernetes environment. Doesn't matter where you're running it. The first that we'll go over here are security contexts. And if I just go ahead and zoom in a little bit more on this manifest, notice under the spec, you're going to see this under the container configuration. There's going to be the security context. And the security context is really all about privilege. Okay, so what the container can do. Is it read only? Can it escalate outside of the container? And these are all things that are super important, because if an attacker gets into a pod and the privilege is set to true, it could, have close to root access. This just deploys the same way, except you're specifying the container configuration to have a particular context for privileges. Okay, and if we look at the description here, security context holds security configurations that will be applied to a container. Some fields are present in both security context and pod security context. The next thing we have here are pod security standards. Okay, so there are a bunch of different pod security standards that you can set up and configure. And what you're going to do is you're going to put them under your labels. So notice here I have pod-security.kubernetes.io/enforce baseline. And if you look up pod security standards, you can see there's a bunch of different other configurations that you can utilize. But in this case, we're using baseline. And baseline is minimally restricted. So you have three types: privileged, restricted, and baseline. Privileged is completely unrestricted, nothing really configured from a security perspective. Restricted is everything is locked down. Baseline is somewhere in the middle, intermediate. And if you just Google pod security standards, you'll see a bunch of different configurations there. The next is network policies, and network policies are kind of like firewall rules in a sense. So with these firewall rules, let's just go ahead and test this out. So I'm going to run 2 pods, just BusyBox pods, no configurations other than just making them constantly run. They don't exit or anything like that. They're just long living pods to test with. Right? And then if I run kubectl get pods output wide, notice how I have these 2 IP addresses. So what I'm going to do is from BusyBox 2, I'm going to ping BusyBox 1, 10.224.0.104. And notice how these pings work just fine. The reason why is because Kubernetes is a very flat network. So from an ingress and egress perspective out of the box, there's no rules, security contexts, nothing. From an ingress and egress perspective, everything is completely open 100%. So this, of course, isn't good, because we don't want just anything to be able to hit our pods, and we don't want our pods to just have any egress traffic that it wants. So if I scroll down here, notice how I have this network policy, and this is just one of many network policies that you can configure. And this one is just pretty much saying block all ingress traffic to BusyBox 1. And again, this isn't the only type of network policy you can have. You can specify them based on namespaces. You can specify them based on port, like for example, only allow this port into this pod. So what I'm going to do is run that configuration, and then I'm going to try to run that ping again. And boom, notice how we have 100% packet loss, okay? Because that network policy is in place. So this is a really, really important one. Remember, with these network policies, you have this flat network. And last but not least is OPA. So with OPA, what you're going to do is you're going to install Gatekeeper. Gatekeeper is like the intermediary between OPA. So you have Open Policy Agent and you have Kubernetes. OPA doesn't know how to speak Kubernetes and Kubernetes doesn't know how to speak OPA. Therefore, you need that shim in place there, and that's what Gatekeeper does. So you install Gatekeeper via Helm, and then you have a couple of different configurations that you need to implement. The first is your config, and your config is the definition that tells Gatekeeper what it can set policies for. So in this case, we're saying only pods. Next, you have your constraint template, and these are the rules that you want to configure. And if we scroll down here, notice there's something called Rego, and Rego is the configuration language for OPA. So notice here we're creating this constraint template. We're giving it a name of block latest tag. And then if I scroll down here, I can configure the constraint itself. And notice the constraint is actually the block latest tag object or resource. So if I scroll up here, as I create this, I'm actually creating an object or a resource within Kubernetes. I'm extending it via the Gatekeeper API, and I'm creating the object or the resource here that is specifying the policy that I'm putting in place. And those are a few different ways that you can secure your environment from a pod perspective right now. This will maybe take you, a day or so to get this bare minimum up and running, which is really great because if you do this, I can guarantee, at least 30% of your misconfigurations will be caught with one of these 4 things, which will ultimately secure your environment in a much better fashion.